Hey everyone, getting ready for your CUET chemistry exam? You know how some topics are just an absolute goldmine for marks, right? Well, today we're digging into one of the biggest ones, alpha hydrogen. Let's go get those guaranteed marks.
Okay, be honest with me. When you see questions about Aldol and Cannizzaro reactions, does your head just start to spin? Do you get all mixed up about which one happens when? Yeah, you're definitely not alone. But trust me, that's all about to change. Because over the next few minutes, we're going to install a super simple decision-making tool right in your brain. And it's going to turn these questions into some of the easiest marks you'll grab on the entire exam. So you're going to want to stick around for this.
So here's our game plan. First, we'll talk about why this is such a goldmine for your score. Then we'll absolutely nail the core concept. After that, we'll break down the 3 key reactions you have to know. Then, and this is important, we'll lock it all in with some practice so you can spot those tricky traps the examiners love to set. And we'll wrap it all up with a super fast revision for exam day. You ready? Let's do this.
All right, first things first. Why should you care so much about this one little concept? It's simple, really. It's all about getting maximum marks for minimum effort. See, the CUET exam is obsessed with aldehydes and ketones. But here's the secret sauce. Almost every single tricky question they throw at you comes down to one simple check. And that is there an alpha hydrogen? If you can answer that one question, you've basically just unlocked a whole bunch of potential marks.
Okay, so let's get to it. The one definition that really rules them all. I'm not kidding. Everything we're about to talk about, every single reaction, every trick, it all starts right here. Let's break this down nice and easy. First, you spot the carbonyl group, right? That's the C double bonded to an O. Got it? Okay. Now look at the carbon that's directly attached to it, like its next door neighbor. That is your alpha carbon. And guess what? Any hydrogen hanging off that specific carbon, boom, that's an alpha hydrogen. That is the entire secret. It's just about being the direct neighbor. So, why do we care so much about this one little hydrogen? Well, here's the deal. It's acidic. Think of that carbonyl group next door as being really greedy for electrons. It's constantly pulling them away, which makes this alpha hydrogen kind of weak and exposed. And that makes it super easy for a base to come along and just snatch it. This is the first domino that falls, and it triggers everything else we're about to see. So once that base grabs the alpha hydrogen, this super important thing is born, the enolate ion. Now, its superpower comes from something called resonance. You see how that negative charge isn't just stuck in one place? It gets to move around, which makes the whole thing stable. But here's the cool part. It's stable enough to hang around, but it's also really aggressive. It wants to go attack other molecules. That makes it a perfect nucleophile. And you've got to remember that word, nucleophile.
Okay, the foundation is built. Now for the payoff. Once you get this alpha hydrogen thing, you can predict 3, count them, 3 major reactions. I want you to picture this like a simple flowchart in your head that you can pull up on exam day.
Okay, this slide right here, this is the entire playbook. Seriously, just look at that first row. The only question you need to ask yourself is, does this molecule have an alpha hydrogen? If the answer is a big yes, then boom, you're going down the Aldol reaction path with a dilute base. If the answer is no, and you're looking at an aldehyde, then you're taking the Cannizzaro path with a concentrated base. This one simple question, I'm telling you, they will test you on this over and over and over again. So let's say you do have that alpha hydrogen. Here's the story of the Aldol reaction. Step 1, a base shows up and creates our hero, the enolate ion. Step 2, our enolate hero goes on the attack, targeting another molecule. Step 3, they join forces to form something called a beta-hydroxycarbonyl. And sometimes in step 4, if you add a little heat, they'll kick out a water molecule. And that's pretty much the whole story.
Now, this is a classic CUET question. They'll ask you, why do molecules like formaldehyde or benzaldehyde do something totally different? And the answer, the big aha moment, is because they cannot form an enolate ion. It's that simple. No alpha hydrogen means no enolate. And if you can't make an enolate, the Aldol reaction is just impossible. The molecule has no choice but to go down a completely different road. And that brings us to our third key reaction, the haloform. Now, for this one, you're basically playing a game of spot the pattern. You're looking for a very specific visual clue, that methyl ketone group, the COCH3 structure. If you see that and it's mixed with a halogen and a base, you're looking at a haloform reaction. The most famous one by far is the iodoform test. It gives you this bright yellow solid that basically screams, hey, I'm a positive test. And here's the classic trap you need to watch out for. Remember that ethanol also gives a positive test. Definitely put a big star next to that in your notes.
All right, theory time is over. Let's lock this knowledge in. Because, knowing the rules is one thing, but can you actually use them when the clock is ticking? Let's find out. Time for some real exam-style questions. But wait, before we dive in, here's a super simple memory trick for you. If you see a molecule with no alpha hydrogens, just say to yourself, nope, it can't do Aldol. That word can't should immediately make you think of Cannizzaro. So remember, no alpha, go Cannizzaro. I know it's a little cheesy, but trust me, it works every single time.
Okay, question number 1 is up. Take a good look at the options. Your only mission here is to find the one molecule that has an alpha hydrogen. I want you to pause right now, figure it out, and then press play when you've got your answer.
And the correct answer is C, acetaldehyde. Did you get it? Let's quickly see why. Formaldehyde, well, it doesn't even have an alpha carbon, so it's out. Benzaldehyde has an alpha carbon, sure, but it's part of the benzene ring and has 0 hydrogens attached to it, so it's out too. That leaves acetaldehyde, which has that perfect setup, an alpha carbon with 3, count 'em, 3 alpha hydrogens just waiting to react, and that's why it's the only one that can undergo an aldol reaction. All right, next one. This is a quick recall question. We saw this in our comparison table earlier. The Cannizzaro reaction is a specific type of reaction. What's that keyword I'm looking for?
The answer is disproportionation. You absolutely have to know this term. All it means is that the very same molecule is getting both oxidized and reduced at the same time in the same reaction. So one molecule of the aldehyde gets oxidized to a carboxylic acid, and another molecule of the same aldehyde gets reduced to an alcohol. It's kind of like a 2-for-1 deal.
Okay, everybody, listen up because this part is really important. Knowing the concepts is great, but avoiding the common traps that examiners love to set, that's how you actually secure those marks. So let's go over the classic mistakes people make. All right, let's diffuse these traps. Trap number 1, don't you dare mix up benzaldehyde and acetaldehyde. They are polar opposites. One has alpha hydrogens, one doesn't. Got it? Good. Trap number 2, always check the reagent. Aldol uses a dilute base. Cannizzaro needs a concentrated base. That one word changes everything. Trap 3, remember the ethanol exception for the iodoform test. I promise you, they love asking about it. And finally, you have to know your products inside and out. Aldol gives you that beta-hydroxycarbonyl. Cannizzaro gives you 2 things, an acid and an alcohol. You have to drill these differences into your brain. Whew, we've covered a lot. So now, let's boil it all down to the absolute must-know facts. Think of this as your final, super high-yield revision list to look at right before the exam. Here we go. This is your mental checklist. You see a carbonyl compound? First question, alpha H present? Yes? Think aldol with a dilute base. No alpha H, and it's an aldehyde? That's your Cannizzaro with a concentrated base. You spot that special COCO3 group? It's gotta be Haloform. Remember, the hero of the aldol reaction is the enolate ion. And if you see the word iodoform, you are looking for that yellow precipitate. Seriously, this one slide is the key to so many questions. And that's a wrap. So I'm going to leave you with this one final thought. From this moment on, whenever you see an aldehyde or ketone on your CUET paper, what is the very first question that needs to pop into your head? You know it. Does it have an alpha hydrogen? Answering that one question will set you on the right path almost every single time. So how'd you do on those practice questions? Let me know your score down in the comments. And hey, if this made you feel even a little more confident for your exam, why not join our community of awesome learners and hit that subscribe button? Keep up the great work, and I'll see you in the next explainer.